through in this, I'll have podcasted so you'll be able to see them and do extra practice. So we have two types of uncertainties. We have what's called absolute uncertainty, and that's the actual uncertainty in the value. That's what we did in the lab yesterday. So it is what it is. It is what it is. The percentage uncertainty. Why did it go so far? The percentage uncertainty is calculated. It's the absolute uncertainty expressed as a percentage of the value. So to figure out percentage, we know we're going to multiply something by 100, some fraction by 100. And what we're going to do is the error divided by the value multiplied by 100. So, absolute uncertainty. I'm going to show you a couple of values, and my question for you is which of these is the least precise? Which of these is the least precise, A, B, or C? Which is the least precise of those values? Cool. Do we need to know an accepted value for this? No. What would we be looking at if we were looking at an accepted value? Not precision, but accuracy. Absolutely. Thank you. So we're looking for the least precise. C is absolutely the correct answer there. I would like to know next which of those three has the greatest uncertainty, the greatest absolute uncertainty in the measurement. Okay, greatest absolute uncertainty is C. So let's write this down. So our same answer for both of them. So we said the greatest absolute uncertainty, and what did we also say about this value? What was the first question? Least precise, yeah. So least precise and then greatest absolute uncertainty are going to be hand in hand if we're looking at values. I've got one more question for you looking at these values. And that is, which value likely came from a digital scale? So thinking back to yesterday, analog versus digital and errors. Which one likely came from a digital scale? Couple more seconds. Excellent. Let's end this one. And the majority of you are saying A. However, if we're looking at final digit places, we're in the thousandths there, we're also in the thousandths there. So if it's in the same location, we know that it's analog. so we can cross that one off. This one, we're in the hundredths place and the thousandths place. So this one, the 6 of you that said B, you got it correct. Pat yourself on the back, that's fantastic. This one we can do a double check just to make sure there's not 2 right answers, which would be a bummer. We're in the hundredths spot and the hundredths spot, so that is the same location. That would be analog. Questions on that? Okay. So, let's take a look at percentage uncertainty. So we're going to look at this and calculate it. And we said on the last screen, oops, I'm going to let you guys do a numeric answer for this one. We said on the last, or 2 screens ago, that we have the error divided by the value multiplied by 100. So I'm going to start writing it out. You can click in your answer once you get it. I would say start with a 0. 0 point, it's going to be something after that. Think about significant figure rules. Now I'm going to tell you, when you're dealing with sig figs, this 100 that you're multiplying by, don't look at the number of sig figs for that one. That number doesn't matter. The values that do matter are the error value and the actual measurement value in the lab. So look at those sig figs and think of those sig fig rules, and then click in your answer. I believe under the @ symbol. How many sig figs are in 6.243? Good, I heard it. 4 sig figs. What about in the value of 0.005? Yeah, 1 sig fig. So now all you have to remember is the multiplication division rule. Get those answers clicked in, please. I'm going to put 20 seconds on the clock. Okay, the majority, let's see, good. The absolute correct answer is 0.08, or 0.08 if you didn't do the 0 out front. So 7 of you got that one correct. If you put a 0 behind it, then you are trying to be too precise. So that one would not be correct with sig figs. And it looks like this one was just, didn't multiply by 100. So that would be the answer for that one. Let's look at the other ones we've got. Some of you definitely didn't look at the sig figs with those 2 answers. This one rounded too much. Same with that one. This one looked like it was probably multiplied by 1,000 rather than 100. So a lot of really close answers, but the correct answer with 1 sig fig, 0.08. So we had a lot really close. Let's look at the next one. Do this one quickly. Again, we're looking for percentage uncertainty. Think about those sig fig rules again. Again, please start your answer with a 0. 0 point something. Gonna going to put 20 seconds on the clock. Five more seconds. Okay, let's see how we did. If you round, I believe, at least this is what I have written down when rounding. Okay. Yay, our highest percentage, got the right number of sig figs. So looking at the other values, you just needed to round up and not just truncate, by the looks of it. Question so far? Yeah.
Is it supposed to have like the same amount of sig figs as like the least amount in there, so then you pick another one?
No, because this one, the 3 is the only one that matters here.
Oh, okay.
So it would just be 1 sig fig. Good question. Okay, we're gonna not do this calculation because I want to ask you a question instead. So, is the error likely A, systematic, or B, random if the accepted value is 5.879, looking at those 3 data points? Couple more seconds. Okay, and this one. And the majority of you are saying systematic. I would agree with you because all of them are clumped together, so they're precise, but they're not accurate because they are above the value. Okay, so if we have a calculation, which you're going to be doing later on tomorrow with density, we have to adjust our error values to match what we have done in the lab. So, some general rules. If we are adding or subtracting, we have to add the absolute uncertainties. If we are multiplying or dividing, we add the percentage uncertainties, so we have to do some calculations first and then add. And if we are raising to a power, we multiply the percentage uncertainty by that power. So, just a reminder, when we're adding or subtracting, we add the absolute uncertainties. So in the following equations, or all the examples that we're going to do, we're going to have x is equal to 581 plus or minus 4.0, and y equal to 42.0 plus or minus 0.05. So if I want to do the calculation of x plus y, I want to know the absolute and percentage uncertainties. So if I'm looking at the absolute uncertainty, that's the easiest for me. We're just adding the uncertainties. So I have 4.0 plus 0.05. Now I have to think about my sig-fig rule here. If I'm doing addition or subtraction, I look at the number of digits behind the decimal point. So right now, behind the 4.0, I have 1 digit. Behind the 0, I have 0.5, so I've got 2 digits. So I need my final answer to have just 1 digit. To start out, I have 4.05, and I'm going to have to round, because I need just 1 digit after the decimal place. 5 is 5 or greater, so I'm going to round up. So my answer to the correct precision is 4.1. That's my absolute uncertainty in this calculation. Now to figure out the percentage, I also need to know what these two values added together are. So 581 plus 42.0. And again, since I'm doing addition, I need to look at what's after the decimal point. Well, if 581 doesn't have a decimal point, I can put it in at the end if I wanted to. It's got no numbers after the decimal. The 42.0 has 1. So that means my final answer needs to have nothing behind the decimal point. Calculate that, let's see, 623. That's my actual calculation of x plus y. My absolute uncertainty is 4.1. So to figure out my percentage uncertainty, I take 100 multiplied by my error, 4.1, divided by my calculated addition, 623. And now I'm doing division, so I need to look at how many sig figs are in each. I have 2 sig figs in 4.1 and 3 sig figs in 623. So my final answer needs 2 sig figs. And I get 0.66% after rounding. Any questions so far? The next one is done in exactly the same way, except my value is going to be different. I'm not adding x and y this time, I'm subtracting x and y. So I would have 581 and subtract from that 42.0, 539. And my absolute uncertainty is the same as it was here. Because whether I'm adding or subtracting, I add the absolute uncertainty. So my absolute uncertainty in both of these is 4.1. So calculating the percentage this time, it would multiply 100 by 4.1, and this time it's divided by 539. Go ahead once you get the answer, type in, once I click to start, go ahead, type in your answer. Again, start out with a 0. And think about the sig fig rules we just talked about. I'm going to put 20 seconds on the clock. Okay. 7.5 or 7.6 would be good. And let's show the rest of them. Okay, so good job. Got the majority of you getting the right number of sig figs. That is fantastic. I rounded early in mine. Okay. Now, multiplying or dividing, we have to add percentage uncertainty, so we have to calculate first. We're going to use the same x and y that we did before. And I want to know the percentage uncertainty followed by the absolute uncertainty. So I add the percentage uncertainties to figure out my percentage. So I would have 100 multiplied by 4.0 divided by 581. Bless you. And added to that will be 100 multiplied by 0.05 divided by 42.0. When you get an answer, go ahead and click it in. Again, think of those sig fig rules. We're doing division, so we need to look at total number of sig figs. Yep, yep. Ends this in just a few seconds. Okay. And okay. I would say best answer, oops, 0.8. It'll take 0.80 or just 0.8. So about a third of you are getting it. Some are still rounding either early or later. There's going to be some error in it, and multiple answers will be counted correct on the exam. Okay. From there, we can calculate, I'm going to go with 0.8. Percent. From there, we want to calculate the absolute uncertainty. So I'm going to actually do this multiplication, 581 multiplied by 42.0, and I need 3 sig figs. Either way that I do this, I need 3 sig figs. Is that what you guys got? 24400 when you multiply 581 by 42 with just 3 sig figs?
Yeah.
What is it?
Yeah.
Okay.
With 3 sig figs.
Yep. I need the 3 sig figs. So that's the first part of it. Now to go back to the absolute from the percentage, I just have to turn that into a decimal. So I'm going to be dividing by 100, or if you know your rules about being able to move the decimal, you're just moving the decimal over So 2, 4, 4, 0, 0, plus or minus, let's see, oh, I forgot one thing. That whole thing gets multiplied, excuse me. So 24400 multiplied by 0.8 divided by 100. And we need 1 sig fig. So I believe with 1 sig fig it's 200. Somebody double check that. So 0.8 divided by 100 multiplied by my value, 24400. 1. Excellent. So this is my absolute. It's my value plus my absolute error. The easiest one to do is the final one with the power. You just multiply by whatever that whatever the percentage is by that power. We're not going to do the example right now because, period 3, you're my Park Pride winners. If you are dressed as a young person, come on up to the front. We'll vote on young first. Little kid. Anyone else? Awesome. No, Aaron's our winner. Is there anybody dressed up as an old person? Yeah. Roy and Gabby, both of you come on up. So you're an automatic winner. You can go into the lab. I'll be in there in a second. So now the rest of you are going to vote. Let's do Gabby as A and Roy as B. It smells like old people. Oh, that's hilarious. Okay, let's get those last couple. Again, Gabby's A, Roy's B. Okay. And this one, let's see. Roy, you are our winner. So you can go into the lab as well. I'm going to take a picture of my youngin' and my oldin'. All of your clickers can go back in numerical order. Please turn them off first. Where did my camera go? There's my camera. And prize box. Okay. So I'm going to get a picture of upgrade
I'm Rachel. I'm my practice tomorrow. That's insane. Ew. I know, like we are all so excited.